Hello.
Hey, let's see how many people we could get in here. Probably give people a couple minutes to roll in. Hey, all. Just gonna give people maybe one more minute, 2 more minutes to cycle in. Okay. Probably enough people here to start. If you haven't seen, we put together some documents on the proposed transaction pool for frame transactions. This was one of the points that was brought up on All Core Devs about 2 weeks ago now. So the first document, if you haven't seen it, it's a HackMD where we enumerate a few strategies that we believe would be sufficient, both in terms of safety and in terms of providing some good usability for frame transactions. The first strategy that's outlined is allowing only the sender to pay for the gas of the transaction. So there's no paymastering, no gas abstraction. And we feel this is like the most straightforward way to enable frame transactions in the mempool. The exact rules are kind of specified in that document. But it's important to note that even this first strategy gives us most of the functionality that we're trying to provide with frame transactions with account abstraction broadly. The second strategy is the one that we're currently recommending as our preferred approach, but I'm happy to discuss this more, and it's up for debate on what the best approach here is. But the second strategy is that we also allow a canonical paymaster. And so we had the insight that with 7562, which is the third strategy, the full AA transaction pool that has totally permissionless support for any contract code running as paymasters or as validation code. The insight that we had was that a lot of the machinery of that ERC was focused on building a reputation system around paymasters and around untrusted paymaster code. And so we feel that we can come up with a canonical example of a paymaster either as an ERC in a Solidity contract or as some sort of precompile. And that canonical paymaster can conserve 95+%. Oh, sorry. That paymaster can serve 95+% of the use cases that people have for account abstraction. And we can very safely do that in a much simpler way in the transaction pool. So that's what the second link is that's the PR to the EIP to actually add that strategy, fully specified in the EIP. And then there's the last strategy that I kind of mentioned. This is just the everything strategy, the 7562 as outlined, more or less just adopting it as 8141. So those are kind of the strategies that we've looked at. I was talking to Julia a little bit, and one other strategy that maybe is worth mentioning is that we can continue to ship frame transactions in the protocol and do a lot of the hard work needed to deliver it as a protocol feature, but we don't have to, on day one, even support it in the transaction pool. My preference is probably to not do this and to have some support for it in the transaction pool, but it is a valid option that I think we're open to if that's how clients feel we need to approach this to get this done safely. Okay, so that's kind of what we've been up to the past, week and a half. I'm happy to open the floor now to answer questions about that or just any questions broadly about frames or AA. Seems like we have a lot of people here.
Can you clarify all of these strategies also use tracing to validate the storage accesses and so on?
I wouldn't say necessarily tracing. So it's the question of does either this can be done with tracing or it can be just done by adding some kind of policy to the EVM that basically signals when one of these rules is met.
Yeah, I don't know if there was specific motivation for that question. Is it about the tracing mechanism itself, or is it this complaint around needing to do tracing in 4337?
Yeah, I was asking because I have heard that as one of the points about um, how this is not viable in the mempool. But yeah, just wanted you to elaborate.
I think maybe one other thing I can add on is that it's important to understand the way that 4337 was introduced to clients was very much like a bolted on thing. It's not something that was really implemented natively, at least not in Geth. We did build a tracer that was focused on this, but it was using our tracing system, which is built to be extensible. And yeah, maybe there's some complaints. I don't know if it was about the Geth implementation of that or if it was about the implementation in other clients. But it's just important to say that with frame transaction, this is a core protocol change, and this type of things are being integrated natively into clients. So tracing, we don't, I wouldn't call this us implementing tracing. It's kind of like Felix said, yeah, we had to look through the transaction, but it's not like we're using RPC trace call and having the brittleness of this that people experience with 4337.
Yeah, this is a good point because in 4337 they built the mempool to be an external thing that sits outside of the full node and operates as its own process and submits the transactions that it sees to this node via the tracing. And we wouldn't really do it like that. I mean, it has way deeper integration with the mempool, and I also don't think it's going to be that complicated in the end to enforce these restrictions, because basically what this mode of operation is it has some very natural boundaries, and it is kind of easy for us to it's a bit similar to the static call as well. In static call, we have this is one way of implementing it, definitely. With static call, there are restrictions on execution, and these restrictions are applied directly in the EVM. And you can either implement it like that, or you can use in Geth, for example. It could also be implemented by using the tracing facility internally, but it wouldn't also incur as much overhead as submitting it to another process via RPC, because the tracing in itself isn't going to be like the slow thing there.
I also want to point out that there's another approach that has been explored by some other AA proposals to minimize the overhead of, this, whether we call it tracing or like some other process. But basically, this other option is to essentially whitelist a certain validation logic, right? So for example, like one idea that has been discussed is that like maybe firms can target precompilers directly, right? And if they do, then the mempool can simply whitelist a set of precompilers which have non-validation cost, right? So just want to flow that as like another potential idea to explore, if you want to really minimize the mempool.
I think on that, like targeting precompiles would be awesome. Where would the configuration live for like? I know we can't, trust that, and we know that not all validation can do like a recovery of an Ethereum address. Or I mean, you could pass the public key and have some sort of address be spit out or something. But like, I haven't seen that proposal for 8141 yet. Just wondering if there's been any more thinking on that.
So I don't think I got the question.
Yeah, can you repeat
Did
the
you?
beginning of?
Derek just saying that targeting pre-compiles with frames. I guess I'm just asking, like, I haven't seen that discussion of how that would work.
So it would work. We have moved a bit away from this in this particular proposal because it is one of these options that is there, and it makes it very easy to do this, like allow listing in a mempool, because you can basically just check if the what now in the let me actually give a wider point. So in Matt's document, if you have seen it, he defines this term, which is the validation prefix of the transaction. So we really want to stress in this document that there are certain frames in the transaction which are related to its validation, and then there are other frames in the transaction which are related to its execution. And I mean, it's one of the things about the frame transaction proposal is that these things can be a little bit mixed, which is good in some cases. It enables certain use cases that like frames have this like multiple purposes, and we also consider it elegant, but for the purposes of the mempool, we have to basically determine what is the validation prefix of the transaction. And the validation prefix is exactly these frames that contribute to the validity status of it. And it is very easy to analyze the frame structure, and it's basically free in the node as well to do that. And you can just walk it and then say, okay, I have determined that it is the validation prefix of transaction considers of these frames. And then you can just check that the target of these frames belongs to a specific set of precompiles. And this is a valid strategy, but it does lock you into, first of all, having to define these precompiles, which we haven't done yet. So that would be something, these precompiles would have to specifically be designed to perform the transaction approval. So we haven't spent too much time defining them, but it is pretty easily possible. And then the other thing with these precompiles would be that, I mean, in some ways it kind of locks your chain into this very specific way of handling the approvals. And so, I mean, ultimately it shapes, I mean, it kind of shapes like how this is supposed to be used. And we were more trying to see, like, for us, this is kind of like we would go there if there's no other option, but we would just prefer to see how far can we get without restricting the user's choices too much. And we feel like just by having the validation gas and predefining these patterns and so on, we basically allow the user to employ any mechanism that they choose to validate their transaction, while at the same time then making it like possible to optimize like some of these things more specifically. With the precompiles, we basically, again, back to this thing where we're giving them a fixed set of choices that they can use. So yeah, I don't know. We're basically not really looking into this too much, but I want to highlight that yes, this is very much an option, and it is kind of easy to implement as well.
And with that initial exploration of that, like, is like key rotation still possible using this precompile path? Like, it seems like there needs to be a configuration for the account live somewhere such that,
yeah,
like,
well, that's kind of the thing. It's more the question then is like, how do you specifically structure this so that it becomes possible? And yeah, I mean, with the key rotation, in some way it's not really possible. Like with the precompile, it would be more like, I mean, yes, it's possible, everything is possible with precompile, it just depends on the complexity of the precompile. But kind of what we were thinking about in this initial idea, like when I voiced this particular idea early on, I was mostly thinking that this precompile would be used to determine if the sender address is somehow related to the public key in some kind of obvious way. So basically, for example, you could have a precompile that checks that the hash of the public key that made the signature is somehow related with this address that is submitting the transaction. And this is something that can be done by the precompile very easily. Yeah. So, but then it's not, if you do this, then the key rotation is out. Like there's no
I have, yes. Sorry, apologize for the bad microphone. I thought I would also share a different idea, like basically the thing that I just shared on the side, which is basically that if you do in protocol enshrined code delegation, which is like itself a very easy EIP that has a lot of benefits for other reasons, then a user accounts would be able to just delegate themselves to a precompile, and so like that basically gives the same sort of UX and API as accounts declaring their account types. And to every precompile that represents a signature scheme, which would include K1, it would include R1, it would include like other things that we do, then basically we just modify those precompiles so that if they get called with approved bits, then they like also assume that there is a sig hash, and they like essentially do the signature validation. And if you do it that way, then one benefit is that if you do the enshrined delegation EIP in a way that supports upgrading, then like basically you do get upgradability for free, and like probably upgradability just is the most natural way to do key rotation. So yeah, I mean, in terms of kind of features, like that kind of approach definitely would limit you to single key per account. I mean, if you wanted to do multi-sig, I mean, realistically, I mean, obviously, we always have the theoretical option to make a precompile for everything, but probably the realistic thing is like you just have a piece of EVM code that makes multiple calls, and realistically, that's like 50 EVM steps, and it's not that bad, and that's one of the things that you could whitelist. I mean, there's always a boundary of like at some point, if you want to start supporting more complex things, then like by far the easiest way is to just open up the EVM for it. But there is a flexible space before that.
I think like on this topic, like there was that recent schemed transactions EIP that broke down the like gas requirements for some quantum types, basically running in the EVM versus natively. I haven't like actually double checked that those numbers were like super accurate or anything, but I think it kind of comes back to like we're really looking for based like native performance, and 8141 is just hard to get that, I guess.
Yeah.
Yeah.
If I may, oh, sorry, go ahead.
No, go ahead, Dave.
Okay. So actually, the numbers are quite incorrect in the. I think you're mentioning the EIP proposal from Julio. Yeah, he missed a few things. A big one being the public key is like in his accounting, he puts it in the call data. You can do it. Yeah, I expected this. So you can do it differently. You can actually have a contract where you store the public key, and then you can just do one excise copy, and you don't need to have this in the call data all the time. So he did a few mistakes on the calculations, and so we are probably also not going to pursue the entity precompile in favor of a more generic solution. And he also forgets to. So in his conclusion is that Falcon is the best scheme, which by gas number is true, but Falcon has also a bunch of drawbacks because Falcon is not very easily implementable on hardware. So you can have side channels attacks, and yeah, so it's it is a good scheme, but it's not an ideal one for a blockchain use case. So we could not have a hardware signer, or it would be very complicated to have a hardware signer. So yeah, as someone who has been working quite a lot on these different schemes, I think he missed a few things in the both in the gas calculation and in the conclusion. That being said, I would love to see some of these schemes make it into the Ethereum one day, but yeah.
Yeah, I think a couple of things I would add is that there's like two possible paths there, right? One path is that we do just add the Falcon as a precompile. That's kind of the boring base case, right? And if you do that, then basically you like I would argue that's like it has an important advantage over just like Falcon as a transaction type because you get to support Falcon, like single key Falcon just by default, but then you would also be able to support multi key Falcon with like basically the same precompile plus a tiny bit of EVM code, like the same multisig. But there's also like something a more ambitious approach, and this is like really new information, and it's quite cool. So this promising new approach, it's it's a vectorized math precompile. So it's like for Python developers, the way to think about it is like it's basically NumPy, and or at least like the small subset of it that lets you do stuff like NTTs and everything that you need in Falcon. And it's looking very possible that with that approach, you'll be able to get gas costs down to the point where it's like call data cost of the signature is potentially half or even dominating. And like the benefit of this kind of approach is basically that we don't have to commit to Falcon in this kind of hard way in the protocol. Like you just have one precompile, and then if like 8 months later suddenly the world decides Falcon sucks and it goes to FNDSA, then the exact same precompile works. Or if the world decides that lattices suck, then actually the exact same thing also works for accelerating Poseidon hashes. So it's so it's a super flexible solution in that way. So we have both paths, and I think if we take the 8141 approach, then the actual decision point for choosing one of the two is still quite far off.
I just want to highlight that for us specifically, like in our group who is behind the 8141, it was the main motivator for us that with the frame transaction, the users are able to experiment with signature types, and it doesn't require a fork to do that. And if we cannot foresee the set of precompiles that will be in the chain in the future, but I definitely have seen it in the past that like adding precompiles is kind of an easy extension point than other things. And for us, it basically, as soon as enough support is added to the platform to make certain signatures possible, they can already be used in basically every possible scenario. So, for example, if we were to add a Falcon precompile, then immediately you would be able to use the Falcon not just for signing the transaction with 8141, but also with, for example, using with another contract and so on. So it kind of gives you like this idea where you have a single extension point, which is these precompiles that add features to the platform that would be impossible or like prohibitive to implement directly in EVM. And then at the same time, you can do all the things like key rotation, uh, multiple signatures, having signing things other than transactions, all of that. Whereas with the if you only support signature schemes, a selected list of signature schemes for the transaction signing, then you still need to solve that other bit in a different way. And I think this is kind of where this for us is like the key thing with the frame transaction, that like just it can leverage the existing extension points that we have in the protocol to enable all the signing, including the transaction origin.
Yeah, I think I'll just also add like we made 8130, which I mean the key property that we like about it is like people can still permissionlessly deploy validation logic as a contract, and then wallets can like add that configuration to accept that. But when a transaction comes in 8130, we can see, just because it's explicit in the transaction, what the validation logic is. And that means like we get this kind of nice property where people can experiment on this like slow path, expensive path with contract EVM logic. And we can also just add a native override without having to like trace anything for, specific pieces of validation logic. And that means like, if we went with 8130, we would, roll out with, a K1 native validator, WebAuth, P256, like, kind of all the main ones that we would care about. And if, a new standard developed, we could just, automatically upgrade all wallets to using this native path instantly with a fork or whatever. And it's also beneficial to mempool rules as well, because then it's just easier for nodes to know exactly kind of what validation logic will run. And that's kind of the one. Yeah, go ahead.
I think the 8130 proposal is like, for me, it's more like, I think it could, like with 8141, the 8130 could also be done as an ERC. So then it would be like a really strong thing where you say, users are really supposed to use this registry. And it's gonna be something where that can feed into also the mempool rules and everything. Like we could still decide to go with like 8130 and just be like, this is the canonical way to declare what your account wants to be validated by. But I don't see it as a proposal that like, I don't think it should be enshrined. And the 8130 has also a lot of complexity, which is then all these specific details that can also be resolved in the EVM.
Yeah, like I think this is where, like, it would be great if we could agree on some place that this configuration should live. Like 8130 is probably more complex than it needs to be, because it's trying to maintain portability across the EVM without the L1 blessing of like, okay, this is the place where an account can delegate its validation logic to other contracts or whatever. I feel like, if that piece was present, then like that gives Base the ability to really optimize and try to compete on transaction throughput with chains like Tempo that have fully native validation, etc.
I mean, I don't think it's prohibitive. You can still, even with like, I think the way we see it, or I see it specifically, is that the frame transaction is like the lowest common denominator in terms of infrastructure, and you can do a lot of things on top, including this type of registry, and it makes your job a lot easier actually, because you can all do it in the user space. And you can put as many policies as you want. You can even put the policy in your block processing logic that only allows transactions which specifically use this registry. Like you can make it as strict as you want, but the point still stands is that we see that like the 8141 is kind of a superset of a lot of these proposals because you can ultimately just implement them, and it just requires like aligning on the specific thing that we want to do for the validation. But it's, for me, is somewhat independent of the protocol level mechanism of implementing this.
Like I do agree that it would be I think where there's a disagreement is like 8130 in 8130 cannot be implemented in 8141 as it is today because the restriction of the frame being requiring it to go to the approver, sorry, of the wallet. Like there's no delegation method anywhere, so it can't be done as an ERC. In 8130, we only run the validator logic, and the configuration is in a single, like, it's in a known state in the account
Yeah, I
configuration.
understand that. It has some advantages to do that this way. We actually discuss it a lot. Like, it's the difference between having to, for example, in a lot of cases that I have analyzed, when you are building your account with 8141, then the account basically will you will pretty much always have to store something in the storage of your own account to configure, for example, which key is currently used. Like the public key which is being used is very likely going to be held, like in 99% of cases, it's going to be held in the storage of the account itself. And then this is one of the key learnings for me from 8130, that it could also be done in another way, where you basically have a global table of which key is associated with which account. It's just another way of storing the same information. So that's kind of how I see the difference between these proposals. And then, yeah, there has to be, if you want to do that on 8141, then there has to be this link between the account and the table. But that is something where, like, for example, delegating to a precompile could come in, or like there's many other ways to do that. But there are advantages to having everything in one table. One of these advantages is these ideas like validation only state, like the VOPS that was discussed. So then you can have a node that basically only holds this table in memory and doesn't have to hold all the storages of all the accounts to look up their keys. So yeah, there are some advantages to that, and I'm really open to discuss it. But from my point of view, it's like 8141 is kind of like it's like a slightly different angle, basically, where we're trying to get in, where it's like more fundamentally about this agreeing on this platform that we can then execute these ideas on top of.
Yes, and I agree with that. I'm just saying, in its current form, we can't build 8130 on 8141. And I understand, like, there could be a new EIP to like extend that configuration somewhere or put and put it somewhere, but it's just not there today. So I'm just, yeah.
Maybe something fundamental here. The thing that, like, for me is very confusing is we are bringing up 8141 as a proposal for the headliner, but we don't see it as a finished EIP. It's like we see it as this is like the starting point where like the discussions can start. We do have some strongly held points, which is like, for example, we really want to do it with like via the frames, because we feel like it gives, like, there are some things there where we thought a long time about this, and we feel like it's kind of the distilled knowledge from many attempts at account abstraction. So we feel like certain things we're going to have a really hard time paddling back on. But at the same time, I do see that the specifics of how exactly accounts are going to work, we don't really have too much of an idea how that's going to be. We want to leave that open. It's just much more for us about like making this EIP the focus of the fork after the next fork, so that there will be ample time for the core devs and also the ecosystem to work out what account abstraction will look like when it comes to the mainnet natively. So in some ways, I feel it's a bit weird that now we have to prove it like right on the deadline that everything is going to be perfect. But literally all we want to agree on is just like, this is going to be our focus. We don't actually want to agree on all the details right now. So to that end, I mean, the main thing that we have to agree on is that like somehow this EIP has to make it possible to do all these things that we want to do. So there has to be post-quantum cryptography on chain, like, and that means, for example, eliding signatures from the block ultimately, or having some kind of mechanism to compress them. Like, that has to be possible with 8141. Sponsoring, like gas sponsoring of transactions, has to be possible with 8141. Like account configuration has to be flexible enough to, like, so that when we ultimately figure out the scheme that everyone's supposed to use, then like that has to be working. Like, possibly this like precompiles this validation, like all of these ideas, they have to be possible with the proposal. So they will shape the proposal for now, but I don't think we really have to agree on like how exactly it's going to look. So that's, for me, just like really important. And that's kind of also what I like about 8141, because so far we have been able to mostly do everything we would ever want with it. Like, it's been pretty rare that we hit some limits where we're like, oh yeah, this is not possible. And if we hit that limit in our internal discussions, for example, we were always like, oh yeah, how can we change the proposal to make that possible while maintaining the properties like mempool safety and so on. Like, this is like the balance that we really have to strike. Like, everything we're discussing here comes with the pretext that ultimately it has to be compatible with the mempool. It has to be safe, and so on. Like, there are some of these core things that we want to achieve, but we kind of intend to make this proposal flexible enough to do all the ideas that people have and want to do, and we're really open to be discussing these ideas.
Or could I ask a question? Who's responsible for finalizing the proposal between now and the fork? I think it's mostly the authors, or the authors of 8141. But in terms of like, finalizing, what does that mean? We're making a decision tomorrow on all core devs to decide if framed transactions is going to be the headliner. And at that point, it's the question of the client teams, like, is this something that we want to work on going forward? I don't think there's like an expectation that the EIP is totally final when it's picked as a headliner. Like, we're still over 12 months away from when this would go live, and things will come up over time as we actually implement everything. But it's basically a matter of getting it to a place between now and tomorrow where client teams are supportive of the frames, and then from there, it'll be mostly on the authors in the beginning months, and then all client teams as we get closer to the fork to get it into like a finalized position. So Lucas is saying that things that the Nethermind team dislike about frame transactions is: one, running EVM transaction in the pool, complex rules to potentially do it safely, and two, complex rules on special mode to run authorization frames. I don't think I understand the second one. Do you mind expanding that?
There are like rules on what is allowed and not allowed that is different than the normal mode, right? So it introduces a lot of complexity.
But you're talking about in the transaction pool still there?
Not sure, would have to look it up, but in the spec. I think it's not related directly to transaction pool.
Yeah, I think what Vukash means is the approval. So we have been working on the approval for a bit now. The current state of the EIP, the way the approval works, we are not super happy with it either, because it kind of has like this has been feedback, especially from Derek's side, that working on this for a while, it can look very confusing. In the end, it's not that confusing if you look at it very closely, but basically there is this problem in the EIP as it is structured right now, that there are two main places where the rules are sort of laid down. One of them is this, what we would call the frame execution loop. So this is in this top level section called behavior. So in the EIP, in this section, we detail how exactly the frames of a transaction are processed while running a block. And then it has these variables there, payer approved and execution approved or sender approved or whatever. And then so basically these variables are influenced by the execution of the frames. So we want to note that this loop specifically is the logic that runs while executing a block. So in its on its own, this loop is not that complex, but the way the text is written makes it look like pretty complex, but is actually like in code is not very complex. And then there we have the other big place where the logic is, and that is the approve opcode. So the approve opcode has some specific restrictions in place that basically tell when this opcode can be used with a certain approval scope. And I agree that first of all, between these two places, they are not right next to each other in the specification, so it's a bit confusing. But also the interaction between these two things seems complex, but actually it's not really complex. In the end, it's just that at some point in the transaction, the approve opcode has to be used with both scopes, and the limitations on the approve opcode make this whole thing kind of safe. And we spend a lot of time optimizing it, but we also heard the feedback from multiple people that the way it's written now is it is kind of hard to understand it, and it seems like this opens up a lot of big matrix of cases that have to be considered. But actually, when you break it down, it's not really the case. So this is something that we heard, and we are working on improving the EIP to make it more clear how this is meant. And for example, there's a proposal from Derek to simplify the approvals, and yeah, I mean, we are aware of this problem.
Yeah. And also, I have just wanted to share a bit more of kind of big picture philosophy, right? Which is that there's a lot of use cases here that some of them get into this long tail of needing more programmability, and a lot of this kind of like custom logic that you can't really fit into existing frameworks easily, right? And so, like for example, one of the things that excites me is that I use privacy protocols often, and privacy protocols today have this weakness that they all rely on this public broadcaster mechanism, and that's like this very specialized set of intermediaries for this one thing, and so half the time it breaks, and so on average I have to like try 5 times before a railgun transaction works. And one of the many things that can happen is basically that like you can make privacy protocols work inside of frame transactions with either a paymasters or the 2D nonce mechanism, right? And then at the same time, there's clearly all of these sort of much more normal or like much more of a small deviation from the status quo kind of use cases. So things like supporting R1, things like supporting post-quantum algorithms, things like supporting multisigs, and the general kind of framework that I think we're advocating for is to basically say, do the generic thing in protocol. And it turns out that in protocol, the generic thing is only a relatively small number of spec lines of code. And then at the same time, like, yes, be very restrictive in the mempool, and the mempool can be, over the strategy one or strategy two, the mempool can be a whitelist. The mempool can basically just be the equivalent, like a whitelist that is equivalent to the thing that something like tempo transactions could include. It could even be just K1 and R1 and multisig. And basically, once this is done, then people who care about the more complicated things have their own space to cook, right? And basically, there's this, they'll have their own space, or I guess we will have our own space to go work on figuring out an ideal universal mempool that covers everything safely. And that's something that happens separate from the protocol that all of the nodes would incorporate into the mempools by default. Any people are free to opt into it, people are free to not opt into it, and basically more and more things could get inducted into the mempool over time as we become confident that they're safe, and all of that can happen without hard forks, right? So right, yeah. So I think that that's kind of the top level vision, right? Yeah, and then I think for each of the individual use cases that gets kind of talked about, right, the maximum allowed timestamp, like there's ways to make safe mempools for each and every one of those things, and I think the exact shape of the safe mempool is gonna depend a lot on the balance between basically how strong the level of like comfort or discomfort with even limited amounts of EVM validation is, and what kinds of use cases people wants to enable quickly, right? But essentially, we get to set up this environment where the default mempool is one set of decisions, and then separately, people who wants to do things that are more ambitious than the default mempool are free, like have their own space to go and do those things by themselves, and then convince like either the default mempool or independently convince nodes and fossilers and builders or whoever else to support it. And so it's this kind of basically free market approach that really minimizes the need for any sort of, or at least much central planning of these use cases once the at least the basic decision of the framework is made. And I think yeah, and from like within that kind of scope, there's a lot of options to make sure that like specific use cases that add up to like 95% of like current usage or people individual projected usage, then that can be done, and there's ways to make fast paths for it so that, like, for example, EVM cannot does not have to be required at all, and so forth.
Um, the EVM would still, regardless of the mempool, the EVM would still have to validate all the rules when including the transactions in a block. Is that correct?
The EVM would need to run the verify frame, but that's an EVM call. Like that's no, like within the EVM, that EVM call is just an EVM call.
Yeah. Okay.
So in talking about the split between the clients and the mempool, from the point of view of everybody who's not a client, but from wallets, applications, users point of view, it's really the combination of what the client does with the frame transaction and what the mempool allows. That's the interface that they use. And so I think it is very important to actually work to define what those mempool rules initially would be, because that's going to be actually the API that everybody sees. And enforcing those mempool rules is a part of what the work that client teams will need to do. And I know we want to end up with a free market kind of environment, or, something I've heard a lot, but it's really important that there's a standardized core that everybody can implement to, so that you don't have to, if you write one set of rules, it only runs in one place. Now, when you're pushing the boundaries and inventing new things, that's great to be able to do, but you do have to have that core that everything runs off of, and that core is basically the rules, the combo of the mempool rules and the EIP rules. Just throwing that one in there.
Yeah. Yeah,
And it,
I think that's very reasonable. I think I mean like as I might have mentioned before, right? Like Bitcoin, like does something similar where it has the concept of what the blockchain allows, and then separately it has the concept of standard transactions. And standard transactions is something much more restrictive that like bans a huge number of complicated things. Yeah, and I think there is a path here where we basically like agree to come to a decision point at some point pretty soon of basically are we going with a default mempool that incorporates like some level of some support for EVM with some restrictions, or are we going for a whitelist mempool? And that's like we get to that decision point, and then we like whichever of those approaches we choose, we can disagree and commit to it, and everyone who finds themselves outside of that can like be feel free to coordinate separately on custom mempools.
yeah, and I think, defining that is a core part of actually defining what work clients have for implementing 8141. So yeah, it's
Mhm.
critical that it actually goes in basically at the same time.
Yeah. So I saw Matt, like wrote up the documents today with three possible strategies, right? I guess I'll just repost it for convenience. I guess would one thing be helpful is kind of also extending that and adding, like strategy 4 and 5, and options that are even more restrictive and whitelist based, so that we have something concrete on that side of things that people can look at and see if they're comfortable with them or prefer them.
I mean, obviously the mempool's a dangerous place in terms of MEV and so forth. But one concern I have, so for instance, for the um, strategy one there, it's sort of saying sponsored transactions will still work, but only through bundlers private flow. Um, I'd prefer there were open enough rules that worked in the mempool where you didn't need to rely on the only way to achieve inclusion or use of this is through a third party, if that makes sense. It
I mean,
should be,
that is what's in there
Yeah,
though, right?
I agree.
Like that is strategy one. You can yourself relay the transaction through the mempool.
Right. Strategy 1 says that it's sponsored transactions that require bundlers. I mean, one thing that I think I can also add is that like we do have the option to mix and match different dimensions. So for example, I think it's a totally valid choice to say we're going whitelist on signature algorithms, but at the same time we're going option 2 style, and saying that gas sponsored transactions whose signatures are within the whitelist can be included in the public mempool. Like I think that is a choice that we totally can make.
Like what I understand you describing is an option that wasn't specified but is a possibility if people
Hmm.
wanted this,
Right.
which is to just not let people submit frame transactions in the public mempool. Like that wasn't specified as a strategy, but it's if that's what we need to
I
do
Well,
to start with,
no, no,
no, no,
I think that would be completely the wrong way because then it's
yeah.
only a feature that can be
okay.
used by third parties. It's
Yeah.
nothing, it's not in protocol,
Okay.
and
I think
therefore,
we agree on that. So strategy one is that users get to use frame transactions and they get all the account abstraction benefits. They just have to pay for their own gas. If you don't want to pay for your own gas and you want to use a paymaster, then in strategy one, we would rely on a bundler like today. It's not our recommended approach, but I can appreciate that it add like allowing the paymasters in the mempool does add more complexity than some clients might be willing to undertake in the first iteration of this.
Yeah, but having it in the mempool therefore gives you that standardization that people can iterate on. Whereas if it's, something only you only get if you're submitting the Titan Builder and they've got all the private order flow, then it's not a good feature. It's what I'm highlighting.
I guess I don't
Where
understand the difference of that versus today. Like we're trying to move away from that. That's the goal. But like that is how it works today.
you mean, yeah, and then I'm just saying, so we shouldn't be developing a feature that will only get picked up by that private order flow. It should be,
But we're not. Like
I accept what you said, but I'm saying, yeah,
so you prefer strategy two to allow paymasters in the public transaction pool. Okay. There's a question, what's the issue with the canonical paymaster? My thought on the issue is that some paymasters want to have some different functionality and behavior, and in general, when we say that there is like one universal way of doing something, that usually can't describe the nuance and complexity of everybody's use case. I think that's the main issue with the canonical paymaster. I think my argue against that is that paymaster is a pretty like single dimensional role in most ways, and if we were to canonicalize something, that's probably an okay role. All right. Any other questions, guys? Yeah.
A bit of a technical detail, but when people say full 7562, one of the rules there is about what they call associated storage, which is storage outside of the account. Is this included when you guys say full 7562?
That's my intention.
Okay.
Any last comments or questions, guys? I think you have to tune in tomorrow, Barnabas.
I have a question because
Yes.
you mentioned that there should be only one frame transaction per sender. Why is that? Can you give more reasoning about this?
Sure. The reason that we're intending one pending frame transaction per sender is because the frames are a native batching mechanism. And so any type of like stacked transaction flow that you have today, you should be able to represent in a single frame transaction. And even if you do it where you submit your frame transaction and it's still pending and you want to append more methods, then you can always do replace by fee. So like we generally don't feel like there are many use cases to have multiple pending. I think that like it's not a hard requirement that it's one pending transaction, but I think it's a trade-off of like the more pending transactions you have, the higher the resource usage and risk is. Like if the verified gas is 100,000 and we only allow one pending transaction, I don't see why it wouldn't be also okay to have two pending transactions at 50,000, or like some like reasonable decision there. So that's kind of like how we came up with one. But if we need two, like we could potentially do two.
Okay, interesting. Do you think it will potentially clash with the 16 million gas limit?
Why is that?
I don't know, because well, if you're bundling things, etc., you can probably easily go beyond that limit, right?
Yeah, I mean, I think this was like one of my arguments against the 16 million limit in the first place. But my thought was more that it was a problem if you have like multi-user bundles. And I think we're actually moving away from the multi-user bundle because that's like how 4337 works. 4337 is like really the main or only use case of having like multiple different user ops in the same transaction, which is like what I was afraid of. But with frames, we're trying to actually like decentralize the bundler more and have it be, the users interacting directly to the block producers or the block producers. And so in that case, the block producer is doing the bundling of all the user ops and the transactions just like they normally would do. And in that case, like you don't need to have multiple user ops in the same transaction typically. So, like, will a user want to consume more than 16 million gas? It's possible, but I think that that's the same question that we also had with pre-frame situations. Like, if a user wants to use more than 16 million gas, it's just not possible. I don't really think there's many users who are trying to do like a batch of operations that cost more than that. Okay, we're 1 minute over now. I'm happy to answer more questions asynchronously on Discord in the ETH R&D or in the Telegram AA Mafia, or feel free to DM me. We will have all core devs tomorrow, 1400 UTC. I'll share the link in the relevant places before then. Please come on if you're not a client developer and you have perspective that you want to share with the core devs about supporting or not supporting frames. We would appreciate that. And otherwise, I will talk to you all tomorrow.
Thank you.